fuel cell team with Professor Brower as our advisor. I'm Gabrielle Cobos.
I'm Wayne.
Better dancer.
And yeah, so let's get started on our. Okay, so the motivation behind our project was we had increasing data center demand, but fossil fuels are limited and they create a lot of pollutants. And also the electric grid is increasingly unreliable. So we want to use alternatives like wind and solar in order to provide power for our data centers. So what we're going to go through today is our goal and objectives, a little bit about data centers, a little bit about renewable energy, why they're good and bad, and current and future work that we've done and that we're planning on doing, milestones and things that we've done throughout the year, and things that cause us to deviate from our initial plan, and just the overall big picture and what we've learned. So our main goal is to improve energy efficiency and sustainability, reduce pollutant emissions, and eliminate energy grid reliance of data centers. And we're planning on doing this by using fuel cells, clean renewable energy, and energy storage. Our objectives this year were to integrate wind and solar power with energy storage and fuel cell, design a server system as a model, and design a 100 megawatt data center based on that model. And now Calvin with data centers.
So the standard data center is around 100 megawatts nowadays. That will power about 16,000 homes. And most of it is powered by the country's electrical grid, which is mainly going to be fossil fuels. And that's about 12% less efficient than if we powered it directly from a fuel cell. That translates to, for 100 megawatt data center, that translates to, if that translates to another 200 kilowatts of power that we need to input to produce the same amount of energy if we use it from a fuel cell. If we use it from a fuel cell, we use 200 megawatts less than if we use it from a regular power plant. And so we also like renewable energy to go with this. This is clean, but then there's also a problem with it. It's going to be intermittent, like solar and wind. You only get it during certain times of the day. And then other kinds like hydro and geothermal, you can only put in certain parts of the country where the resource is available. So obviously you can't just put down the data center wherever you want it to. It has to be in a specific location. And these, right now it's new technology, so it's also really expensive to produce. And most of it is going to produce less energy than traditional power systems. You see on the graph on this right side, solar isn't on it, but it'll be about the same as hydro, which it hovers around 30 to 40%, whereas coal and natural gas will be 50, 60, 70%. But in the future, we hope that as technology increases, the cost to create this kind of electric power is decreased, and it'll also become more viable as we use all the fossil fuels that we have. It's going on fuel cells. It just put fuel in, air in, and it creates a chemical difference for the electrons where we get the power from, and as an output, we only get excess fuel, heat, and water. So it's pretty clean technology. We also have a pretty good efficiency compared to internal combustion engines. Right now, the highest is about 60%. And we chose PEM fuel cell instead of solid oxide fuel cells for this, because it has a lower operating temperature, only 80 degrees Celsius, whereas solid oxide, things like 600 degrees Celsius. Yeah. And fuel cells it'll also be easier to maintain than engines, because there's no moving parts in it. So there's going to be a less chance for something bad to happen, less maintenance to do, and it can just pretty much run continuously without that much supervision over it. But as with renewable energy, it's newer tech, so it's going to be more expensive. This graph on the right has the past costs and then future projections. But hopefully it continues along this declining trend of cost to energy. But then also with fuel cells, it takes longer to start up than a regular power plant, and you still won't get as much production, which is why we need to use fuel cells along with renewable energy to get enough energy to power it. And on like for the system design?
So basically our first quarter was spent researching all this stuff, the renewable energy, fuel cells, what we could incorporate into our model, our design of how we're going to power a 100 megawatt data center. So after we did all the research, we had to come up with a way of what exactly are we going to do, how are we going to use these resources, how are we going to use different power plants to make the energy that we need for such a large demand data center. So 100 megawatts, that's a lot. So Terry kind of helped us out with this graph, coming up with good illustrations. But so the main idea is most efficient would be just to take direct wind and solar power and power your servers with that without using any inverters, any energy storage, anything, just directly to it. You get efficiencies way higher than anything else. All the inverters and power supply units, all that takes up probably close to half of the power. Other losses like transmission aren't as big. But if we could get rid of inverters and other little electrical equipment in the system, we can get a lot higher efficiencies. So, and the reason why we did solar and wind was because we don't really have a stream that we could use nearby here to experiment with. So we could buy a wind turbine, we could buy an anemometer to get wind data, we could buy solar panels to get solar data. So that's basically why we picked those two. But in reality, you could use pretty much any type of renewable energy. So, as Calvin said earlier, So in addition to the solar and the wind, you're also going to need a battery because you might not have enough. You're going to have little fluctuations all the time, so the battery would respond quick enough to make up for that. But you're not always going to have enough power. So in the night, you won't get like any solar, right? You'll get some wind. Wind is typically late evening, sometimes early morning. So you'll get a little bit, but you're not going to get enough to power 100 megawatts. So what we're going to do is, at times when you don't have enough power, you're going to store energy when you have enough power. So say during the day you're making 200 megawatts. You only need 100. So you're going to put the extra power through an electrolyzer, get hydrogen out of that, and then store it. And then when you're at night, you don't have enough power, you can put it through a fuel cell and then power the server rack with that. Get efficiencies of about 70%. 70% is like a theoretical value, so obviously this is like a future design where at this time you're probably going to get 70% efficiency. Now fuel cells are probably closer to 60, 65, especially for smaller scale fuel cells like we're going to be using in rack. But so like Calvin was saying, fuel cells they respond quickly, but they're not very fast. So at times when you start up and shut down, when you need short bursts of power for say a second or two, we're also going to have a battery in series or in parallel with the fuel cell, so you can power the servers for those short durations. So this is basically our design, our model of what we're trying to build. So next slide. And this is our experiment. So our original idea was to we came up with that model, so we're going to make something that works just like that, but small scale, not 100 megawatts, that's massive. So we were going to do about 1 kilowatt. We have a server rack, takes about 5 or 6 servers. Each server is roughly 1 kilowatt, so 5 kilowatts. We could obviously just take servers out. So we were going to use one server and power that with a couple of solar panels and a small wind turbine. So we'd be able to basically simulate our whole entire system just at a small scale. That ended up not really working for reasons why we'll explain later. But also the other, so we have a fuel cell. So we work with the Advanced Power Energy Program here, also the National Fuel Cell Research Center. They're kind of the same thing. But they did a project with Microsoft last year using PEM fuel cells as basically backup power for data centers, but what we want to do is use it power continuously. So we were able to get the fuel cell that they used for their previous experiments, and also some insight on how to use them. Turns out it's not working now, so we haven't been able to use it, but they're trying to fix it, and hopefully next year if you join, we can work with it. So yeah, those are our main components, and so the way we're going to go about doing it, and the way we did do it, so we determined the specs that we need for each of the components. So assuming we were going to go with 1 kilowatt, we need about 1.5 kilowatts because you're not going to get the full power out of a solar panel. You have losses, and same with the wind turbine. So we're going to get 2 solar panels and a small wind turbine to power the 1 kilowatt server. So we ended up buying the 2 solar panels so we could get data from the sun. And we didn't buy the wind turbine because we didn't have enough money. So we got an anemometer instead. It was a lot cheaper, but we could still measure the wind speed. So measuring the wind speed, we could estimate the power we could get out. We have it on top of engineering tower, so it was pretty nice to go up there and see a good view. And then so once we get all the data from the different parts of our project, we'll put it all into MATLAB basically. So we have data from the wind, data from the sun, data from how much a server takes, and then just put it in and see if we have a certain amount of solar, a certain amount of wind, is that enough to power our server? So this is basically our budget. It's not $70,000, $100,000, but we got a lot of help from getting getting a fuel cell and also the servers from the school. So that saved a whole lot of money. And in the future, we're probably going to buy a wind turbine so we actually can get wind power. Hopefully next year we could actually make a small scale full model. And also maybe a fuel cell if we can't get the one working now. We could buy a small scale one. So now Ben's going to talk about the results of our project.
So these are our solar results for a cloudy day. It actually took us a long time to get this because every time that we've tried to acquire data for a cloudy day, it's been partly cloudy, or for some reason there would be a sunny spot right over our panels. And it just changed because of the wind. And as you can see, our max current, or we got this by changing the load and just graphing based off of what we read off of the voltometer. And then these are our wind results. We got this from the anemometer on engineering tower. These results come from the wind speed, but the wind, our anemometers they're stationary, so they'll always be turning. So these results aren't as accurate as we would get from an actual wind turbine that we place on top of the roof or something. And we got these points by averaging every 10 minutes of the wind speed, because the wind would always die down and start back up. But in reality, for a wind turbine, it just takes all you need is the startup speed, and then it would be running for a bit. So these are our milestones. We were able to determine the renewable power characteristics, install solar panels in the anemometer. We made the IV curve for the solar panels and simulated wind power and speed. And the wind power that we simulated is based off of data for the Vesta V90 wind turbine. And we also estimated the total wind energy in a month, which is 125 megawatt hours for that Vesta V90, and we also powered the server rack with solar panels. Back to Gabby.
For our future work, we're planning on using the 100 megawatt data center, our findings from that. We're going to consider other renewable resources, and we want to eventually run the fuel cell once it's working, and power the server with the fuel cell once that happens. Also, we would like to connect both solar panels to the server. Most of the times that we've been doing it, we've been using one. And then measure power consumption over the server. And also run the MATLAB model of our system on the server. Okay, so the overall big picture is, here's us right there. And we have our wind, and our peak power is 33 megawatts. Our capacity factor is 0.3. For solar power, our peak is 290 megawatts. Our capacity factor is 0.31.
So like we said before, we didn't do exactly what we planned, and that's probably pretty typical for every single project, but you can't really do as much as you think in 30 weeks. So what we were originally going to do, like I said, we were going to make a small scale model, but have it running actually. So instead of that, we're basically relying on MATLAB. we're getting all of our data and then plugging it into MATLAB. And also, like I said, you couldn't actually use a fuel cell, even though the project's called fuel cells. So that was kind of disappointing, but we were able to see a fuel cell, a different type of solid oxide, like Calvin said, the high temperature one. The lab has some of those, so we were able to see those running. And one of the people working at the lab showed us how we'd set up our PEM fuel cell when it actually is able to run. So we know how to run it, we just haven't been able to run it. So yeah, basically it boils down to not having enough time, money, and also equipment not working properly. But that's life, I guess. So what we learned, one important thing is to keep in mind that even if people are like ambitious at the beginning, they might not want to stick around the whole time. So you should always have a contingency plan for what are you going to do if you don't have enough people, you don't have enough money, how are you going to scale down your project and still learn what you wanted to learn, but maybe not quite as ambitious. Dealing with people being late sometimes is annoying, coming up with excuses, but you know, that's life, and there's always going to be people that can't show up on time, but you have to make sure that you can keep the project running. And another thing is shipment times. So like we were running kind of down to the wire at the end of the quarter, we're trying to get stuff done before winter break, and the shipping wasn't going well. So we found out that Amazon is pretty amazing. So whenever you can, always buy your stuff from Amazon Prime. And always keep in mind safety. I know like sometimes professors say that, you know, you gotta be safe, and it's just kind of annoying to hear that all the time. You don't really believe them, but when you're working with some like electrical stuff, it can be, like you could get a shock and die. So some of the stuff is pretty dangerous, and you really have to take some lessons, listen to the professors, make sure you know what you're doing, double, triple check everything before you touch something. Another thing we learned was that, so like, we have the help from Advanced Power Energy Program. They have a lot of equipment that, you know, we could use, but some of it's being used, some of it's old, and you don't know like how you're supposed to run it. You can't find any manuals, so you shouldn't really rely on all the tools that you have. Sometimes it's better to just think of a simple way of measuring something. So like one example is when we were trying to measure the power from the solar panels, we had to use part of a rig that was used for the fuel cell. We took that out and used it as a resistor because we can measure the resistance and figure out how much power was going through it. So using little things like that is more important, I think, than having all the equipment in the world. So there's a list of all the members that are in the group now. We had 11 the first quarter, and dropped down to 7, and now 9. So, yeah. Questions?